Hello, my name is Dimitri Hochard. I'm engineering manager at Carlton-Bates in Austin. Back in January 2015, ConocoPhillips approached us to redesign their solar power system for the instrumentation on the field. The original design was a standard solar with 300-watt solar panel, one 60-amp charge controller, and a VRLA 24-volt 800 amp hour battery. With the bad weather condition they've seen this year, they realized they had problem with their batteries and couldn't keep up with their 5 amp load on the field. To accommodate for that problem, they started to install some thermoelectric generator in parallel with that system. A thermoelectric generator, or a TEG, is a device that converts heat into electricity. It does small load between a couple hundred watts to like a couple kilowatt. This one was about 200-watt generator. Some of the pitfalls with that workaround was they still were cycling the batteries, and the batteries were still seeing high temperature and therefore would not be capable of being used when that thermoelectric generator would be down. So let's take a look at the solution that Carlton-Bates came up with. Alright, so this is our TEG solar system that we designed. It's got a single solar panel of 300 watt and 6 200 amp hour batteries for a total of 600 amp hour at 24 volts. To keep the battery as cool as possible, we used a 1/2 inch thick insulation, reflective paint, and we kept the battery spaced out so we could renew the air in it and keep those batteries cool overnight, despite the high ambient in South Texas. The electronic components got moved to this Hoffman CSD enclosure, so the heat they generate would not be seen by the battery in its own compartment. Particularly the heat generated by the solar charge controller, who can generate quite some heat when the solar energy has nowhere to go, being an off-grid application. We're using this little Queen DC UPS unit to switch between the TEG to the battery if the TEG goes down without interrupting the instrumentation load. Every subsystem is overcurrent circuit protected with the little Eaton FAZ circuit breakers, or a fuse in the case of the battery because of the high KIC rating. And we have a little battery management system to keep the health status of the battery and inform the customer in case that battery would deteriorate.